I'm going to talk about prototyping in Node.js. I have a bunch of links that I have in this talk, and I've put them all at that URL, and I may keep adding to them. It's just a gist. But if you kind of want to take something away, just grab that link. You could get it now or after. The biggest thing I learned is that you will build the wrong product. This is something I've had conversations internally, externally, people with failed startups. I'm like, oh, what went wrong? And they're like, oh, we built a thing great. It had all the latest, whatever the front-end framework du jour is. Like, it's a React Redux with this kind of DB. But you build the wrong thing. You solve the wrong problem. This is a big reason why products flop. And they can flop early or they can flop like a year or two into development. But you've built the wrong thing. That's kind of one big takeaway I took away from this. But as I got going, I started to realize there was another thing that would happen, and you will actually build the product wrong. Now, if you're lucky enough to build the right product, you still probably built it wrong. And I'm saying you, it's me. Like, let's just say this is me, and this is me admitting I'm bad at all this stuff, and this is what I learned. But it might be you too. So you will build it wrong. And there's reasons why you might build it wrong. Some of the reasons are that along in the day-to-day, when you're just working on little technical problems, like, oh, I need to connect this to that, and I need to modify this data to that, you'll introduce like these little, it's like tightening bolts. And what that has an effect of is actually has an effect of skewing your project in a certain way and making it hard to do other things later based on decisions you make today. And I'll give you a real world example. Who's gone to IKEA and bought like a cabinet or something like that? Okay, you get home and you're like, all right, I'm going to follow these very simple instructions. And the first time you ever buy IKEA furniture, what you do is you like start assembling it and you tighten the heck out of like one side. And then you go, okay, yeah, this is great. And then you try and put the other side on and like the pieces don't match up. And you're like, oh, and like IKEA furniture is not meant to be undone. So the moment you like buy into that, that's your technical debt. And then the fact that this doesn't line up, you're like prying things over and moving it. This happens in technical projects as well. Oh no, my phone has lost the Wi-Fi. Okay, we build the wrong product. So, 1 second. I discovered this. We have a CEO at our company who is very like hands-on. He loves to prototype things himself. At first I was scared of it. Now I love it. I think it's awesome to have someone who's so intimately involved with product creation. But he really loves this prototype. You cannot walk into his office and say, I'm going to show you a slide deck, or I'm going to show you a mock-up. He will call you out on that. He will want to see prototypes. And at first I was like, you know, oh, we're wasting time. We could do this in a mock-up and we could prove this and prove this. I have come to appreciate the prototype because to me, it has kind of merged these two trade-offs of how to build a product and how to build the product right. And these are decisions that you're constantly faced with, and the prototype seems to be a good job of kind of unifying them. The other thing, this is going to be controversial, but the prototype isn't always throwaway. Some of them are, but eventually some of them actually are kind of in this hazy world between it is a prototype, but it might start to be the kernel around which you build the real product. It's the best way of putting it is it's your guide wire. And another real world analogy is if you had to build a bridge across a span somewhere before we had laser beams and satellites, you know, if I just start with the bolt tightening, I start on one side and I start building the bridge out, little things can happen. Like the bridge can miss where it's going, you build them from two sides and they won't meet up. All sorts of weird things can happen. So this prototype serves as your guide wire. It solves a core user need right up front, and then you make sure you're always solving that. And what that helps you do is prioritize, like, oh, well, I can't solve this unless I boot a bunch of Amazon instances. Well, you're like, that cost is so small compared to the value it's providing. And if you don't have that prototype guiding your way, you can start making little cost optimizations that will pull you away and in the wrong direction. So one thing that was very humbling being on this team was that I often built stuff that only proved we shouldn't build something. And at first I was not happy with that. I was like, I put in all this work and you're just saying we're not going to do this? Like, I was grumpy about it. But as I got maybe about 6 months to a year in, I actually started to appreciate that. And that became kind of my main goal, was to almost anti-prove something by doing a good job of like trying to make it a real product. So I was going to say the best thing a prototype could do for you is tell you how to build it, or is tell you what to build or how to build it. But the second best thing it can do, and this is still an awesome thing, is tell you what not to build or tell you how not to build it. That is the second one has been more my job than the first one. So in my head, this is how I break down the struggle of what a prototype is there to solve. And I've coined these two terms, product and technology, and they have a specific meaning when I'm using them. So a product solves a real immediate human need. This is something that I really like the phrasing of this because it's easy to build something that is not a product. The flip side would be a technology. I'll talk about that in a second, but it has to be real and immediate. The reason I say immediate is it's very tempting to come up with like abstract frameworks or open platforms, and you're like, you can do so many things on this thing. It's like every which way, you know, like this abstraction combined with that one will solve this problem, and this combined with, that's too distant, I'd say, for a product. You can get there over time, but it's too much to ask people up front. So the flip side to this, the other battle that's coming in is technology. And technology is kind of where most of us live and breathe in most of the day as engineers. And technology, I think the best way of describing this is there are platforms that provide a competitive advantage. So the technology that you develop internally is often what you use to kind of separate yourself from people coming in once you've discovered that product that you want. So I have a product that is, I'm not going to use company examples because I totally haven't asked legal, so let's just make stuff up. You know, you have the best donut flavor in the world. Other people are going to try and copy this. If you've refined your manufacturing process and your kind of, what do you call it, like your, you know, pipelines and whatnot, you still have an advantage. You can drop your price. You can scale better. So technology is important. Without it, we can't do kind of what we all do and like take these small ideas and make them massive. But if we're not solving the right problem, then it's going to flop. It's not going to work. You need that one core thing that you're doing, and adding more things on to something that hasn't like taken hold is actually not gonna work. Okay, so open question: how do we build the right product, and how do we build the right product well? So I would start here with like, what problem are you trying to solve? And this is something that I pulled off of Wikipedia. But this isn't the original form that I saw it in. This is the hierarchy of confidence. I saw it in this form originally, so I'm going to tell the story with this form. And the idea is when you're learning a skill, you progress from box 1 to 4. So you start in the upper left-hand corner with unconscious incompetence. You don't know it, and you don't know that you don't know it. This is also kind of like the Dunning-Kruger area. And as you're learning, you progress. You first learn that, oh, here are all the things I don't know. I was not aware of not knowing these things before. A practical example might be we're all building web apps. I bet we all fall into different boxes when it comes to security. So you have web application security, and a lot of us are in box 1. We don't know what we don't know. Like we don't even know that we're doing it wrong. Then we learn a little bit, maybe an exploit, maybe an article we read or something, and you move into conscious incompetence. Well, here are all the things I need to do, but I don't know how to do them. You know, as we progress, we get to 3 where it's kind of like, well, here are the best practices, but they're hard to apply. I got to kind of think about them a lot. It's easy to forget. I got to go through a lot of checklists. And eventually we get to 4, which is unconscious competence. It's like if you know how to ride a bike, play the piano, speak a second language, it becomes natural to you. So someone showed me this out of context of creating products. And I stopped and said, you know what? This is really good for identifying how to build products. I think a product takes you from one of these boxes to the other. And I always try and think about what my product is doing. Now, some of these boxes are harder to move from others. If you're in box 1, unconscious incompetence, and I'm like, you need to buy this thing. You don't first recognize the need to buy it because you don't even know that that's a problem. If it's a security product, well, you need to buy the security product. Why? I don't have security problems. Like, it's really tough to make that product for that person. I used to believe 2 to 3 was where we want to settle products. I've since kind of opened up to the idea that it could be more, but kind of know where you are. What is your product doing? Is it taking someone who knows they need security but doesn't know how to implement it, and you're providing that for them? Well, that's great. That's something people love solving by throwing fistfuls of dollars at you because they don't have to waste their time learning it. So these are good areas to think about when you're thinking about products. This is the other one. I coined this term. Now, I told you we had a really hands-on CEO. But this, can anyone guess what this stands for? Mean time between demos to CEO. This is a super important metric. Now, this doesn't have to be the CEO in every organization, but in our organization, it's the CEO. You can make it whomever you want, but it should be somebody who is kind of high enough to call the bullshit. Like, a few reasons why I really, really like this is a mockup can only tell you so much, and a mockup requires a certain level of buying into the lie of what you've got in front of you. And someone like CEO level, they don't always have time to learn the lie. They're just going to look at it and evaluate it, and that's what you want, that gut reaction. So nothing is as immersive as a working product. Real data changes everything, and they have limited time. You kind of want that. So one of the ways I've gotten there is started to follow this experimental approach of, when I'm thinking of a product, what I look for is like what goal a human has, what problems are obstructing that, what solutions might alleviate that problem, and then question and answer is kind of like, is my solution really going to solve that problem? And I iterate back and forth on this. And what you want to really seek is a high value goal that's obstructed by a big problem. Those are good products because people just want to throw money at you. I've since added this to say you should actually look for existing solutions and weigh your solution against the existing solution. That's actually the true test. If no one has an existing solution, no one really cares about the problem, because if they did care about it, they would be solving that problem right now. Look for something that they're solving in an expensive way. Look for where people are using up their time. That's the most expensive resource most of us have. I'm moving a little quick because I also have kind of a technical portion to this, and I want to balance these two between thinking about product and implementing it in technology. So yeah, I just find that prototypes answer a lot of these questions. They're higher fidelity. Putting real data in a prototype changes everything. I've seen more than one example where we mocked something up and we went, oh yeah, asynchronous can be visualized like this. We put real data in it. No, it didn't look good. So I'm really like just doubling down on the prototype idea. Okay, so you want to build a prototype. How? Here's my initial suggestion. Know your primitives, and then this is a technical sense. We're going to learn about learn some things about Node, the OS, a few other things. Know a lot of tools. I just say a lot because we're building to answer a question. We're not building to be like the most elegant piece of software, by which that usually means some sort of minimal representation or abstraction. And know your goals. Know your goals is important because of that early guide wire concept. If you don't know your goals clearly while you're developing, what you're going to follow is the technical grain of your project. You're going to start building towards whatever your platform finds easiest to build. So if you're in Java, you're like, you model the solution in terms of classes and interfaces. If you're in Haskell, you'd probably think everything looked like a functional program or something. So you want to know those goals because they combat that technical grain that's pulling you away from maybe the right direction. These are my 3 forbidden phrases that I have come to really believe in. Don't say these, and if people are saying these, I guess challenge them as to why they're saying them. But the first one is, this way will be more efficient. So I find that is generally used to like introduce some optimization somewhere that we don't yet need. Efficient is vague enough that like you can kind of hand wave it. If they had a real like, oh, this this is taking 30 seconds to respond when we really want it to be 1 second, that's totally different. But if someone's kind of hand waving and say efficient, I pull away from that a little bit. The other one I would say is we're going to do it right. So I don't know what that means, but I think what it means is the way I view the current incarnation of the product or the solution, I can see that the abstractions underneath, like the classes and the functions, can be compressed into fewer classes and fewer functions. That's, I think, what that means. But the problem with that approach is you're now like tightening those bolts and building for what you have now, when really what you want is a platform that can keep building to accommodate in the future. So that's why I'm kind of skeptical about that one. The other one is we don't want to waste the engineer's time. So I hear this a lot about like building throwaway, like, oh, why would we build a prototype? That's just wasting the engineer's time. Design and product management should go and think of the perfect thing. I actually just haven't seen good examples of this kind of waterfall-y process happening. And I don't believe it's a waste of the engineer's time if you learn something incredibly valuable from it. Okay, here are my do's. Build around the user experience. Kind of start at what the user is going to experience. Do repeat yourself. It's fine to have methods that repeat themselves because you don't yet know if they're actually coupled, and you don't want to prematurely couple them. Build for one answer at a time. This is kind of the you ain't gonna need it. Leverage incredibly cheap compute resources like Amazon instances and Google Compute instances. They're like pennies an hour. How much are all your salaries per hour? There's a huge difference in those costs. And be willing to build the wrong thing many times. This is something that takes a few swings before you're really comfortable with it. My kind of whimsical don'ts are like, don't build for the future, that you ain't gonna need it. Don't really focus on your backend and your tooling to make the most superest, best backend and tooling. Don't refactor and deduplicate unless you need to do the next experiment. But if you finish your code, don't then look back on it and go, oh, I see how the same thing could be expressed with fewer lines here. Because you actually don't know what the next iteration is going to yield. And it may be that it aligns with your refactoring, but more likely it actually doesn't. Don't bother optimizing around storage, CPU, memory. Right now, we're focused on building a product people want and finding that value. And this actually leaves us room to be competitive later. Another incumbent enters the product space, and I'm like, oh, I never even looked at optimizing my compute resources. I'll just optimize them now and cut costs. And then you can just do this huge cost cut. And don't be afraid of, don't be afraid of writing something that gets thrown away. All right, so now we're getting a little deeper into the technical stuff, and we're going to talk about some tools to leverage. I love NPM. I pay them my $7 a month. I highly recommend everyone do it here too. It's a small price for all the stuff that they provide. And everything is on NPM. That is that's a module that will tell you if a string is the title of a Fast and the Furious movie. Like everything's on there. And that one's a joke, but there's a lot of great stuff. And what I really like is that all the modules are small and composable. They generally work around these simple JSON, like plain old JavaScript objects, or an interface like a stream or an event emitter. There's just a few primitives that they all communicate with, and wiring things together between like radically different modules is super easy. I'm going to talk a little bit about proxying crazy things for other crazy things in a second. The search is so-so. I think even they will admit that. So I tend to ask on Twitter, search GitHub, look at package.json. Unfortunately, that discovery piece is a little weak. And it's okay to have lots of dependencies in your prototype. Every dependency you have is time you saved coding. And what you're trying to optimize for right now is your time. Here's a few cool NPM packages, ND-array for numerical computing. I've used etcd.js for etcd stuff because I've been doing a lot of cluster orchestration things. Level up, in a pinch if you want like a DIY database. Esprima, this is a technique I'm going to talk about later that takes JavaScript and produces an abstract syntax tree from it, and you can manipulate it. Xterm, PTY. I've done a lot of TTY hacking, which is, TTYs are totally crazy. Talk about that in a bit. Markdown parsing, it's awesome. This is another great technique I learned. So now you're at your company, you go, I want to build a prototype. I've learned all the rules. And we have a servicified app, and you're facing this application that has 2 dependencies, which is 3 dependencies. And you're like, oh God, I got to boot this whole thing on my stack just to build a prototype. That's a nightmare. So what I recommend is don't go that way. Electron and Chrome plugins actually let you inject scripts into sites as they're loading, and you can essentially hijack it. This can be your site, this can be another site, you can pull 2 sites together. But what you can do is alter the front end look and feel of your product just by browsing through this Electron app or this Chrome plugin. This is a great way to really rapidly prototype a change to your site. You can get around from CORS issues. I mean, all these things are going to matter at some point. You can't ship an Electron app to all your customers. But doing this saves you so much time. You can iterate through. Remember that first slide was you're going to build the wrong product and you're going to build it wrong. This helps you find what you actually should build and give you some clues about how to build it before you even make that first investment. And generally, this is like, for a lot of people, this is under a day of work. Okay, this is something I found extremely handy, and from here on out it's going to be fairly brief, but I would use them as kind of index points to look up later. I found knowing my protocol super handy. So just a little bit about TCP. Anytime you have 2 services talking, they're talking over a network, and almost certainly they're using TCP. TCP is going to give you bidirectional streams, so if you need 2 things to communicate with each other, it's probably going to be over TCP. Only problem is there's no framing, meaning if I'm sending you a payload of data, there's no indicator as to when I've gotten all the bytes for that bit of data. It's single band, so like if I'm sending one thing, I have to wait and then send the other, and then it's like, hey, where's the boundary between those 2? So people often introduce protocols on top of TCP, and my advice would be, if you start inventing your own, you will eventually re-implement HTTP. So just go from HTTP from the start. Now, there's a few criticisms I hear about HTTP, which is people want duplex connections and open sockets. So there's two ways to get that in HTTP. One is through the upgrade header that you can send. And if you look in the Node documentation, the Node will actually give you a bidirectional socket if someone sends an upgrade header. So you can use this to basically open a channel that you can put anything over. And then you can even do, like, if you call this route, you get an open channel. This is how WebSockets work. The other is the connect method. This is actually used for HTTP proxies, but there's nothing stopping you from just writing your own implementation of that connect header, or that connect method when HTTP connects. And I've done all sorts of crazy stuff with that bidirectional. I've sent, I'll tell you in a second here. And if you want to do streaming, HTTP, plain old HTTP can do it. If you're just streaming in one direction, use chunked encoding. And chunked encoding is essentially framing. And you can just send it. Now, I don't know how web browsers respond to this. I think you need something called server sent events. But if you're talking between two services, just use chunked encoding. And you'll get the data in a streaming fashion on one side. There's also TLS. Not much for me to say because I'm more in the prototypey space, but just not everyone knows. TLS just wraps an arbitrary socket. It's not like HTTPS isn't like its own protocol. It's just these two things unioned together. I think self-signing is fine for when you're prototyping in your own data center. I don't want to get into this too much. Now, HTTP 2, there's two modules here that are awesome, both by Fyodor, who works on Node. He also is the one who cracked the Heartbleed challenge on Cloudflare. And he implemented the Speedy and HTTP 2 protocols for Node. They're awesome. I would highly suggest using them. The second link on there is even cooler. It's just the protocol. It's just the framing protocol. So you can actually send that over any socket. And just to tell you a crazy experiment once, I opened a connection this way, did that upgrade to a bidirectional stream, and I sent a Speedy connection in reverse so that your client connects to the server, and then your client is now a web server that this thing can send requests over. You can do all sorts of crazy stuff. This is just in Node. I can talk about that after. You can do it unwrapped. You don't have to use TLS. It also supports raw sockets. DNS, what's cool about DNS is most things use DNS to like figure out where they need to go. If you can intercept that, you're almost like proxying the underlying layer. So I used proxying DNS in my container orchestration. Data, just a sequence of bytes, but which I mean is JSON's pretty good. JSONs is my new line delimited JSON streaming format, where you have like each row is a JSON entity, and you can use this for streaming. It makes good streaming format if you just send them one row at a time. gzip compresses it like a boss. Oh, also JSON parsing hates your CPU, but that's okay. CPUs are cheap right now. Thrift results may vary, but if you want to interop with Java services, you probably have to go. There's a few weirdness things of it. One thing I want to note about numbers is a lot of people complain about 64-bit integers not being supported in Node because they're using like a custom protocol. Very often, unless you're trying to add those 64-bit numbers, you can just unpack it into an array buffer that's 64 bits. So this is just a thing that came up, and I'm telling you. Proxies. Oh my God, I love proxies. Node is the proxy champion. Learn to write proxies, it's like 25 lines, like just an HTTP proxy. And I say proxy everything, like getting control of all the things I want to resource when I'm doing a prototype is so powerful. I don't have to deal with CORS issues and tokens here and there and all sorts of logging in. Like, I love writing proxies in Node. I probably tried to proxy everything and everything. Yeah, everything can be proxied. You can proxy, I'm gonna skip this. Okay, now here's another thing I find is handy to know. I'm just gonna go through your kind of Unixy essentials. Learn about the parent-child process hierarchy, because if you're prototyping, often you're gonna boot other processes and try and coordinate them. And just knowing some basics about this is what you wanna do, like how to send signals between processes, how to do like spawn children and reap them when they die. It's all weird, it sounds very morbid when you talk about it. That last line is just my glib little kill-9. Kill-9 is like unrecoverable, like killed dead. The only reason I say that is it kind of forces you to deal with things that would happen anyway. Like things die for weird reasons out of memory. Just kind of forces you to deal with that right away. Files, learn about the concept of file descriptors. Super handy. A lot of people when they talk about underlying stuff. We'll use the term file descriptor. Not everyone's really gotten into it. It's just a number, and you give that number back to the kernel, and the kernel goes, oh, well, I know which file you were referring to. I love bash. You'll use it more than you think, and don't be afraid of using it. And knowing all these other Unix fundamentals really helps when you're using bash. Okay, TTYs. A lot of my prototypes actually start as a command line interface to things. And all I got to say is read that first link. TTYs are total madness. But the main takeaway here is if you're using a TTY to prototype something, very often you're somehow proxying that stream somewhere. And when you hit Control-C, interesting things can happen. Control-C is usually oh, stop. And you want to proxy that somewhere. So my only advice is look up the difference between a raw and a buffered TTY. Buffered will interpret that signal locally. Raw will let you forward it over. Transpilation, I really want to get into this. This is a cool topic. But if you want to let people execute logic on your server, I think this is one of the best ways to do it. And you can write these grammars that will kind of parse arbitrary language. But you can make it kind of as complex or simple as you want. There's the JSON, which is a YAC and parser combinators by Kat, who works at NPM. There's a little bit of overhead to learn this. I do think there's some pretty good rewards, but what you can do is you can then parse something into an AST. You can manipulate that AST into something called the Mozilla Parser API spec, which is a JavaScript object that's kind of imagine an object that describes JavaScript. And then you can use this ES CodeGen package to turn it back into other JavaScript, and you can execute it. And what this does is it actually gives you, it kind of bounds what you can do, and it gives you a fair amount of safety. So it's a pretty good way of letting people execute logic, arbitrarily complex logic, on your systems, which is something I really like. A little bit, oh, I'm actually totally running out of time. So node internals, learn them. There's V8, libuv, some JS glue. V8 is by Chrome. It's what executes the JavaScript, and all I/O that happens in V8 comes from a C++ function essentially that gets kind of proxied in, and you can write your own. Two things to know. Actually, I'm going to skip that. libuv, it's just where the dragons live. I don't know nothing about what's going on in there, but it's super cool. Native code. I'm going to skip over this. Okay, one thing to talk about is Docker. I use Docker a lot. If you're doing that proxying of DNS, Docker lets you proxy, you boot a Docker container and say, actually point your DNS there, and then you kind of take control of it. So if you have an existing app and you want to take control of it, this is one interesting way to do it. Techniques, feature flags. This is something I really love doing, is get your prototypes, even your mockup, into production. Put it behind a feature flag, ship it to production. Oh, it's just an image. There's something amazing about that happening. It just rallies everyone together and puts them on the same page. I would highly recommend people doing that. I'm going to skip that. Let's see. Anyway, yeah, go build awesome things. Thank you.